What's going on, guys? I'm so excited to see you back today. We have a great announcement to announce. We just passed 100 subscribers on the New Hire Theory Dev channel, an accomplishment I never thought would be possible, and I have all of you to thank for it. So let's go ahead and get started in this banger of a video we've got lined up for us. In episode 3, we left off with some incomplete specs when it came to testing all of the functionality needed for navigating between the streamer clips and the clip library, editing clips and making sure all of the toast messages and any error messages may show up. And the reason for that was I started to run into an issue with trying to get Chrome working remotely in our Docker Compose file as its own individual service. And we ended up spending, I think, 2 or 3 streams working on it, trying to make it communicate with Ferrum and Capybara in our test service. And I did go a little too far down the rabbit hole, and I should have just said, you know what, we have a working implementation. It may not be super ideal, but it is working. And as of right now, we don't have the ability to remotely debug the way that we would like to. And that was like the whole purpose of trying to get Chrome working in its own service with Docker so that we could be able to remotely debug the sessions in Ferrum or Capybara and Cupright and all that stuff. The automation tests, we would be able to control it remotely from our host machine and be able to debug tests that we might have problems with in the future. As of right now, the entire test suite is passing. We should have a fairly comprehensive spec for each of the features that we need to test in all of the clip functionality that we have thus far. And if we run into an issue in the future with debugging, we'll revisit it and hopefully we'll figure it out from there. To kind of illustrate some of the issues that I was running into, I saw on Google message board that Chrome had taken away the option to specify when you launch it from a command line, the remote debugging address flag that you can set and have it bind to 0.0.0.0 so that it binds on all adapters, on all network adapters, and that was what we would need for Docker. The group mentioned something about security, which I understand if people are using it in production, binding to all networks that aren't properly NATed or behind any kind of firewall or whatever could definitely be an issue, but it's not an issue in development if we're not using any kind of publicly hosted container service or something. So it's a little frustrating there. And some people said that they got it working. I have not yet. So if anything, this will leave us an opportunity to handle that in the future. And hopefully we can get that sorted out. And it's just part of the problem with development. And that's a big thing that I struggle with, is just not wanting to accept defeat on something that I'm struggling with. But there is a necessary amount of time. That's why the whole time box term is used. We're going to specify this much time will be used. And then if at that point we still don't have a solution, we need to find an ulterior route. And I struggle with that a lot. And I wanted to give it a call out here because that's why episode 4 is getting delayed, is because I just spent too much time on this and I don't have unlimited amount of time to make these episodes and to work on this project. So it was a poor decision on my part that I spent so much time on something that wasn't super crucial to furthering the app's progress and that kind of thing. So I wanted to touch on that and say, hey, you know, I've been doing this for a long time and I struggle with a lot. I'm trying to grow. A big part of what I'm looking to accomplish on the channel is doing that and teaching everything that I learn from now on and what I've learned in the past. So I'm trying to be as transparent as possible with that, and something to definitely keep in mind as solo developers for projects. We really need to be mindful of our resources, and time is definitely the most valuable resource. As a gritty developer, you can get a lot done, but only if you're able to manage your time well. That's something historically I have not been able to do, but have been getting better at, and am looking forward to sharing my journey of getting even better with all of you guys. So let's get back into it here. So the specs that we have are all mainly centered around the streamer clip and clip functionality. If we look back in the application, what we're trying to test so far is the ability for a streamer to upload their own clip that is shareable, making sure that we're accounting for the instance where that clip suddenly becomes unshareable. We had to make a technical decision that would affect the kind of the nuance of what makes ClipShow unique, and it was a decision that I'm hoping will work out. Basically, if you go and add somebody else's clip to your library while that clip is flagged as shareable, and it's not a clip that you uploaded, if the person that uploaded that clip later on decides that they no longer want to make it shareable, whoever has already made it into their clip library will keep it there. And I think that's going to be kind of like the rub, is that if you can get it while it's available, great. If not, you got to go track it down yourself and add it as your own clip. So not super technical, but we have to be both business oriented and technical oriented as well, to be able to get the most out of this for everybody. So it's not a bad thing to just take risks, and this is certainly a calculated risk, and it's something that we might change in the future. But again, going back to the resources thing, we can't spend too much of our resources on these decisions that are not super crucial to the underlying minimum viable product. So in the streamer clips here, and remember in episode 3, we went over how we're using this clips URL, even though the actual models that we're seeing here are called streamer clips. It's a little confusing there because of how we decided to present this, but it's not too big of a deal, I don't think. And then in this public clip library, this is where all of the clips that the streamer currently does not have will be accessible by them. As long as they're shareable, they have to have that shareable flag on them. And if they are, they can add it to their own clip library. And we set a kind of dynamic experience for this so that we don't have to have any page reloads. This will just mark it as added, and then on the next subsequent load, it will not show this clip since it's already in the streamer's library. So all of our specs handle that, and I can go over them very quickly here. I have the majority of them in the, not in the model spec there. In the system dashboard clip library and clips spec. So the most notable thing here with all of this is that we're using our mock successful OAuth flow to sign the user in. Now, if we were using something like devise, we can use the devise test helpers to be able to sign a user in and use it in a declarative way like we are here. Since we're not using devise and we rolled our own simplified version of kind of an OAuth user flow with Twitch, this is what we're doing here to mock those requests that are made on our OAuth controller. So if we look in the OAuth controller here, when someone clicks on the Continue with Twitch button, that actually sends them to Twitch to authorize their Twitch account, and then Twitch will redirect to this endpoint here, and we're making an HTTP request to Twitch, which needs to be mocked as well. And we do some logic here to see if this is the first time a user is signing in. If it is, we'll create a streamer record for them here. If it's a subsequent time that they're signing in, and we already have a streamer record for them associated to them with their OAuth provider ID here, which is what we get from that get Twitch user info, which is another HTTP request that we have to make. We have to make one request to get the token, and that needs to be mocked in our test suite. And then we make another request to actually get the user's info given that authorization token that we are granted from Twitch. So we're mocking those and making sure that we're able to test that a user that is returning to ClipShow that has already gone through the creation process can leverage their sign-in with Twitch to get authorized with ClipShow. And ultimately, we're using that to scope all of the clips for the streamer clip model. We're just calling that current streamer anywhere in our controller. And this integration test actually tests all of that and makes sure that we don't have to create a user each time we're going to run a spec. We can go ahead and use an existing user that we have a factory for in RSpec, and it works very well. So in the before hook here, again, the pattern that we're following is mocking that OAuth flow, and we just have to make sure that the streamer that we have stored here, as you can see, we're using factories to create this, has the OAuth provider ID that we're mocking in this here, which is 1, 2, 3, 4, 5. And that ultimately is what decides whether or not a streamer gets initialized or if we're able to find it from the database. And then this also handles the other user interaction. We click on the continue with Twitch, we visit this URL here, and then we expect the dashboard to be where each spec for this test suite will actually start. So we test when there's no clips that exist, and we are in control of what's in the database for each individual spec. So for this one, we're not creating anything beforehand, and we're making sure that our rendering logic works as expected in this particular scenario. And then when clips do exist and we need to test that, instead of having our specs create clips that we would need for each individual test, we can create them using factories, and it makes the whole process a lot quicker. So we're preemptively creating these clips here that are just factories that we have. And then their corresponding streamer clips that we're ultimately going to set to the streamer that we're signing in using that mock successful OAuth flow there. And this basically makes sure that, hey, there's clips ready to go, and our test should be able to see the actual elements that represent those, and we can test that they show up in the correct order, and we can validate our sorting logic there, and we can make sure that there's nothing else that's going wrong with the app, and that our logic is checking to see each individual streamer clip card is being rendered as we would expect. Since we mentioned that episode 4 got delayed because we spent too much time kind of tracking down that Chrome issue, it's worth mentioning what our current configuration is as it stands. So as you can see here, we've commented out our Chrome service. This is kind of what we were trying to work with and get running on that remote port to be able to debug and see the actual session and see the tests run. So I'll go ahead and erase that. And then in our Docker file here, we're just as a part of the kind of the setup for this image, we are installing Chromium, and we're just setting that up to run on the same service that the tests are running in. I think it's the simplest way. It would make sense to be able to run this in a separate service like we were trying to do to be able to take advantage of the remote debugging, but as it stands, it's just not currently working. So we'll check on, and again, we'll circle back to this if and when we need to. For next steps, I wanted to document this episode a little bit differently. Instead of doing a review of all of the functionality done for the episode and going over everything, I think it might be better, and I would love to hear from you if you agree or not, whether or not you want to see me document the progress as I go. My only concern with that is if I end up recording something that needs to be done again, it might lose the value of the episode, and part of the value is watching somebody that's already kind of figured this stuff out, but also wanting to see how they struggled to be able to get to that point. So I'm going to try to include a mix of both, and I would love to hear your feedback on what kind of style you like, whether kind of a review where I show all the source code but kind of go over it quickly after we've already sorted out the logic, or if you want to get what our live stream always gets, which is the real process of struggling, coming back, doing things over again, and that kind of thing. Which is another reminder, we always stream on twitch.tv/oddjob if you'd like to join us, and you'll see the entire process, all the recording. I'm actually streaming right as we speak, and if you want to take part in that, go ahead and follow now so that the next time we go live, you'll get notified. And that's something I wish was available when I was getting started in my career, someone who's willing to share anything that you would want to ask them that they can answer. It's something that I encourage all of you to take advantage of. So for next steps, I'm thinking we want to start actually implementing the bridge between OBS, which is the software that streamers are going to use to actually broadcast their stream. And that's where we'll have the option to implement a browser embed, which ultimately will just render a page just like this, but we'll have our event listener hooked up to our AnyCable instance, and we'll be able to listen for events that come in, and that will be the primary mechanism of how we're able to trigger the different clips and different ClipShow modules that we'll eventually build out. In OBS, how these types of services usually work that I've seen is you'll have a URL that the streamer will input as the URL for the browser source they're adding to actually make this work. And the URL looks something like this. We'll have our host name here. Maybe we'll segment this under the alerts. And then after that, they'll have this token here that will be their identifier for being able to have these alerts streamed to them. And we'll need to keep this secure so that it's not shared and other people can't hijack into other streamers' alerts, and we're keeping it scoped to the correct streamer. So I'm thinking that we should be able to get away with this kind of approach. And where we would get this string from is when the streamer is created, it will set an alert token, and we're just going to set that to secure_random.hex32. And hex32 will actually return a 64-bit or 64-character string that we'll be able to use to uniquely identify each streamer. Since these are unique strings, we should be able to count on the fact that they'll remain that way and will not be easily guessed or brute forced or anything like that. As an added security measure, I think we should be able to get encrypts working with the alert token column that we're going to need to add to the user record, which is the single table inheritance for the streamer model. And the only reason I say that with hesitancy is I'm not sure if we run into any issues here with single table inheritance. I don't think we will, but we'll find out. So I went ahead and added that, and I'm going to go ahead and add a migration now. In previous episodes, I've just kind of cheated and overwrote the original streamers table migration that added the streamers and the users and all that kind of stuff. And since we are a little further on in the project now, I'll go ahead and start to follow the practice of adding a new migration as we come up with new functionality, but we'll try to keep it limited within the in between each commit. I don't want to have a commit history where the schema was one way and then the schema was overwritten and then the schema was another way without there being any migrations to explain that in between. So since I've already committed since the last time that I've done that, we'll use that as our line in the sand and make sure any additions to the database or changes will be done in a migration. So to do that, we're going to use the Rails G migration command, and we're going to specify add alert token to streamers, and I think this will derive the correct table that it needs to add to, and hopefully this will just work. And we're just specifying one column here. It's a string column. Strings, I think, can be 255 characters. Since they're going to be limited to 64, we should be completely fine here. Okay, that worked, and now I'm just going to go ahead and go into the migration. So we'll go ahead and check to make sure if the migration looks right, and the only thing I think we're missing is an index for this so that we can look up the streamer efficiently based on this unique string, which is what will be happening when the streamer puts this URL in OBS. Eventually that request will make its way to our servers and will identify the streamer based on that string. So that's what we need to be able to make very quick when looking up in the database. And when trying to run that migration, I got an issue because we were declaring streamers. So remember I mentioned we're using single table inheritance, and this is kind of why I was anticipating an issue. Sometimes I don't know if Rails will figure out that we're using single table inheritance or if we have to specify the underlying table name like we appear to have to do here. So I just changed add alert token to streamers to users and changed the name of the migration as well, and changed the table name that we're passing into both of these here. And the migration at least got past that part. Now we're getting a issue from strong migrations, which is the gem that we added to make sure that whenever we're adding a migration, it's going to be production safe and we're going to have the least likelihood of having any issues in production as a result of running these migrations. It's complaining that we're using a non-concurrent index here, and what this will do is block any writes to the database while this index is being built. Even though this database is brand new, we're going to follow the best practices as much as we can here, and in the future, if we ever needed to add an index to an already established production server, this is an approach that we would take. We're not going to sacrifice performance if we miss an index when we don't have the opportunity to rebuild it on the fly. We'll just specify that we'll use this here, the algorithm concurrently, and that should solve our issue here. We have to specify the disable DDL transaction here, and what this does is normally migrations are wrapped in a database transaction, and a database transaction can be rolled back if the entire transaction is unable to complete, which is great so that you can make sure that data isn't being stored in a bad state, but sometimes we have to disable that, and when we're using this concurrently algorithm flag here, it means that we have to make sure that this migration will not be run in a transaction because we cannot build the indexes in a transaction and then roll those back. It just doesn't work that way. So we have to add that flag at the top, save it, and now the migration should run, or the migration did run, and we should be good to go now. Since we made a new migration, we will need to migrate the test server. I just ran into this issue. We had Claude or Cursor, whoever it is. I think it's Claude, yeah. I'm not sure. It's AI overlords. They're taking over. But I think I had them make a spec to our streamer spec here that affirms that we are able to generate a new token on creation
And it even added these here, which I normally wouldn't add. Probably will remove this one. Like, we don't need to verify that it creates it for different streamers. But on alerts seems reasonable, and then also to make sure that it's encrypted, I think should be reasonable as well. So these are the specs that we are going to add for this feature specifically, and because we included a new migration in that, we hopefully will just have to take the Docker container down and then back up again, and I think our entry point will run the migrations, but we'll find out in just a moment. Okay, and we're getting the test passing now, but we're getting a environment mismatch. I'm not entirely sure why this is. Something to do with the migrations and how we have the container services set up, but I don't think there's a real issue there. If there is, I'll definitely point it out. But all those tests are passing now, so we should have confidence that if we create a new streamer record, that it should automatically create that unique channel alert ID that we're going to use to actually authenticate the streamer through their browser source in OBS, and we can move on to the next step in doing that. Now, I'm going to go ahead and test this by destroying the streamer record in the database that is created from when I was signing in through Twitch. So this will emulate a brand new user signing up, and we should be able to have that unique string that we can start to work off of if everything is working correctly. So I'm going to go ahead and destroy the streamer records. All of the streamers are now destroyed. If we go back to ClipShow, we'll go ahead and refresh, and it kicked us out. We'll go ahead and sign in with Twitch. We're already signed in with Twitch, so we just went through that process. And now if we go ahead and reload, we see that we are getting this alert token, and it has a filtered parameter in here. And I'm guessing that's part of the same authentication for the encrypted values. But if we go ahead and access it on the active record object itself, it will get decrypted, and we can see this is our unique string, so we should be good to go. If we consult our mockup that Claude made us originally at the very beginning of the project, this is the section that I'm thinking we'll create now as the widget generator. I'm not sure what all of this will be able to use, but this is very similar to what I think we will ultimately create, having this kind of card functionality. And then I really like the OBS integration guide where we can go over what you need to do, which is just copying a URL that's right front and center that ultimately needs to get put into your OBS. And then that URL will go to a page that ultimately has the alerts shown on it. So we'll follow this here. We'll create a link here in our sidebar, and we'll keep in mind that this is more along the lines of what we want. I'm not sure what this is. Oh, it's a widget preview. Okay. So I guess I kind of understand that, but that's, I don't think, super relevant to us. This is more along the lines of we want something that's blurred right here where you can click show, and then there's an alert that says, hey, keep this secret, blah, blah, blah. Copy URL, and then maybe even a button to reset the URL. So if at any time they think that their URL has been compromised, maybe they can just go ahead and hit the reset button, and that will generate a new one for them that they can use from then on. This theme stuff, I don't think that we'll need. We're going to have a lot of functionality in the future for ClipShow, and I think a lot of it is going to be piggybacked off of this widget. So this is what will handle the actual payloads for showing everything and the actual functionality on the streamer's end for the ClipShow stuff. So yeah, we'll keep in mind that we want something more like this, maybe not with this theme control stuff, and then this OBS integration guide. And we'll keep this like blurred out, and they have to click a button and acknowledge that this is a secret, and we'll go from there. First up, we'll go ahead and add a route entry in our routes.rb, and I don't have anything fancy for this plan. I think we're just going to go ahead and start working on this functionality. It's just going to be /alerts/token, and that should work, and we'll pivot if we need to, if we figure out a better way to do it. Next thing we'll do is create our corresponding alerts controller. So you'll see we're getting a GET request. We're specifying that anything matching alerts, and then this notation here indicates that we'll have this treated in the parameters as the token, right? So anything that we refer to as params token in the controller will refer to whatever is in this string here. And in my opinion, it's a nicer way to go about passing these tokens in, because you don't have to use the query parameter approach with having the question mark at the end, which I think is a little messy, but essentially it does the same thing. We're going to go ahead and have the alerts controller just inherit directly from application controller. And by default, this controller won't have any of the OAuth logic or anything like that. This will be an unauthenticated URL in the sense that there's no sign-in process that they'll have to go through. They're just going to use that unique string as their unique identifier for consuming their alerts. So we'll go ahead and look them up by the token parameter, like we mentioned in the routes.rb file here. And if the streamer is nil, we'll just render a plain text response saying streamer is not found, and we'll give a 404 error. Otherwise, we'll go ahead and render the view. Let's get all that functionality working next. So to get the view set up, we'll need to add a folder in the views folder. We'll need to add a directory under views called alerts. And we're just going to call it show.html.erb for now. And then we'll test the view by just showing a response like this. And this will indicate we have access to the correct streamer based on the token that we put in. And we'll do this in a private incognito browser so that we make sure that we're not leveraging the streamer that may be already set from logging in. It's just something I thought about because ultimately we want whoever can access the internet to access this URL if they're given the correct token, which is why it's such a big deal to keep that stored securely and make sure that the streamer is aware of that as well. We'll actually need a view for the dashboard side of things as well, and I got kind of confused there on what side we were building. And we'll still be able to use this for the alert side, which will go into OBS, and then this will be the actual dashboard view that the streamer will be able to access, and we'll want that on two separate controllers so that we can make sure one is authenticated the way that the other dashboard controllers are set up, and this one is set up separately to not be authenticated. So for that controller, we'll add a widgets controller under the app controllers directory. We're going to go ahead and include the dashboardable concern here, and this is the primary reason that we need to have this in two separate controllers. And for the show action, we can just keep it blank for now. We'll create our new widgets folder here in views, along with the show.html.erb for that as well. And we'll just render something generic for now. And to make sure that our route is set up correctly, we can go ahead and run that Rails routes command that we went over, I think, in episode 1. And we'll grep the output to only filter what matches our pattern here, which is widgets. And we'll get the name of the path. So if we append _URL or _path here in a action view, we'll be able to get the actual URL to this resource here. And this is routing to the widgets controller, so everything appears to be correct. And then in our dashboard layout here, we'll go ahead and add the widgets path link. And we're still following the same active class pattern that we are with the other links that verify the URL and the active class that it will apply that gives it that purple bar on the left of each of the links. And then I've just been using the autocomplete in cursor here, and it's been using emojis, which is fine for now, but I noticed they don't work in the integration test. So we'll need to switch that out for probably the feather icons at some point. But for now, they look kind of cool, so we'll keep them. All right, now that we've added our URL, we go ahead and refresh the screen, and we see that we have a new link here. If we click on it, we are getting an issue. Most likely, this means that we didn't put our HTML in the right place. What actually happened here was there's a typo in the file name, and this is because my keyboard is freaking out and sometimes lags. It's very frustrating. I think that's exactly what happened right there. So now we can confirm after fixing that typo that we have a new widgets page, and we're able to work on this view the same way that we have every other view, or just so far the Clips view. And the first thing that's jumping out to me is the heading here. It's just showing dashboard, and we'll need to specify that content for method in order to change this, and we'll do that now. And I forgot what the syntax is for that. And a lot of the times I'll just, instead of trying to use trial and error to figure it out, I'll just look at the previous implementation that I know is working and just go off of that. So we can literally just copy and paste this. And this should update that header now at the top of the page, but we should have nothing now in the body of the page since we erased that, which does appear to be the case. So we are making progress. Another thing that we'll need to do here that I just realized is add our widgets directory to our style source here for Tailwind. So that's a good call out on Johnny for figuring that out before he get frustrated and said a bunch of swear words that I'd have to edit out. I'm also trying to start getting away from this overly verbose, repetitive classes that we're using in Tailwind and trying to narrow them down into individual classes so that we can start to clear up the markup because it is getting a little out of hand. And I mentioned in episode 1, this is a better problem to have than having a bunch of random one-off styles, which I still stand by that. But I'm just noticing that we're repeating this a lot and we can just make this a lot cleaner in our markup by starting to use this approach here by specifying a class that just applies all of this Tailwind stuff. Now, I don't know if this works with regular vanilla CSS. I don't know if we're going to run into issues, but that is my thinking on that. And we had to add another source to the CSS here so that it's still applying all of the Tailwind stuff. I think this will work. If not, we'll find out very soon. Okay, I just added a new clip and I think it's all working, so we should be good to start reusing this wrapper method here, or this wrapper class here for our widgets components. Again, we're trying to emulate this kind of card type thing, and I think the styles there that we just changed should allow us to reuse this. So in our widget show.html.erb file here, I'm thinking we render a widget URL React component, which we have yet to write. We'll go ahead and do that now. Okay, and I'm going to put that in the JavaScript components streamers widget URL index file. It's getting a little verbose, so maybe we'll adjust that kind of pattern in the future, but I really like having it separated with plenty of ability to have subdirectories if we need to, and to try to keep things concise. Again, it's not super important what pattern we follow, as long as we are following some pattern. That's definitely more important, in my humble opinion, of course. All right, so I'm going to go ahead and give Cursor a prompt to make this widget URL into what we kind of saw in the mockup, and I'm going to see what it comes up with. Sometimes it comes up with something we can work off of. Sometimes it's just complete garbage. So let's see. All right, so we'll go ahead and let's just accept it and see what it came up with. We are having an issue rendering this, and the reason for it is because we actually need to use the current streamer helper method there, I believe. So now if we refresh, we're not getting that error, but we're not getting our component either. Okay, we actually did not import and register this in our mechanism here using our own component renderer. So that should be the issue. Okay, and this actually looks not terribly bad. I think we can work from this. I don't think this is bad at all. I think we can make this work. And listen, whenever I have the opportunity to have something that's more qualified make any kind of UI, it's most likely going to be better than what I come up with. I'm just not good at it. If I have a mock-up to work off of, I'm a lot better, but coming up with it on my own, I've never been able to get down. So if we can work from this, I think this is going to be okay, and we'll dial it in and see if it works for the finished product. But at least the basic functionality seems to be working here. It is actually copying and pasting this to the clipboard, which I instructed it to do, and the styling is a little weird, but I think we can work with this. And I'm also going to ask Cursor to try to spruce this up as much as we can and try to add some instructions on how the URL is going to actually work, similar to what the OBS integration guide is here on the original URL, or on the original mockup. So I basically explained to Cursor that we are adding this type of component. We had this kind of like blurry thing in mind, and it's actually doing pretty well. A lot of this is just really static kind of copy, but it does well at it, and it looks pretty on theme. So I think we should be able to use this. So another prompt that I'm giving Cursor here is to add a reset button somewhere here that makes sense to be able to have the user click and then reset this in the event that they need to do that. I also trimmed up some of the component that they had up there. It's pretty generic still, but again, it's going to push the ball down the field and get us to the next step. And I think it looks a lot better, again, than what I would have come up with. So we'll stick with it for now. So it added this button here. The orange seems fine to me. Maybe we can also have it add an animation once we go to click that to give that an experience, and then it will load back here. Another thing that I'm thinking of now is the kind of test experience. So in Streamlabs, which is another platform that does this kind of streaming alert system, you have the ability to test the alerts coming in. And the idea here is that you copy and paste this browser source into OBS and save it, test that a alert came in, a clip just got played. What would that look like in OBS? Does the sound come through? Does it look right? Is it the right size, et cetera, et cetera? And so we have a lot of blank space here and here. We also want to make this responsive. We want to make sure that we're keeping that in mind. So maybe we push this over to the right and we have like a preview experience here. And I'm going to lean on cursor again to give me just a rough UI of what that would look like. And I'm going to be descriptive about what we're trying to achieve. And since this isn't really anything groundbreaking, AI should be able to understand what we're trying to do and build just very generic UI for us. And then we can go in and wire everything together the way that we need to. That's how I've been using this type of system, and it seems to do well. The less that you have it do, the more that you have it stick with like something that they can follow a theme with or other components to compare. It works really well, but anything beyond that, and it gets really squirrely really quick. For that testing functionality, I'm thinking we'll put that in its own React component. So we're going to follow the same process here. And this is exactly why I like to follow this process, as it normally works out for me this way, is that we, in the streamers section, only the dashboard is going to be there. Underneath this area, the widget, this could even go in the dashboard folder here, but we have this directory structure where we can go widget, test, and then have an index, and we can kind of see that these components are separated and they're simple and they're not overtly complex in their naming structures. So just another call out there to what I notice. So after some back and forth, this is what we've landed on so far. We're using the feather icons now instead of the emojis. We're going to try to get away from that since those seem to be working better. We've got our reveal working here with this token, and we're getting this value through a prop that we're sending in using the Rails routes helper to generate this for us based on the current streamer that's in here. The only thing that we need that we, at this point, can get going is the reset button. We can go ahead and create an endpoint that makes that work and go ahead and update the URL based on that. This test clip experience here is going to be what we'll be working on next. That's going to be the next big accomplishment, and that's going to prompt us to get into starting up AnyCable and making sure that our planned approach with all of that will work. And this is going to segue very nicely into all of that. So to build out the endpoint for that reset token functionality, I'm thinking we'll put that in the widgets controller. We'll just have an endpoint called reset token. And this will get the current streamer, update it with the same type of mechanism that is originally creating it with the secure random hex 32. And then we'll redirect to the widgets path with the notice. So hopefully the toast message will work as we expect it to. In our routes.rb file, we'll go ahead and declare a route for that. Instead of redirecting to the widgets path, we actually can just respond to JSON. We can just keep this an AJAX request, and we can follow that pattern for having the toast message displayed. So I'm just going to copy and paste the respond to block here that we're using in the Eclipse controller. And we may introduce the responders gem, which we can set up to kind of handle this a little more cleanly than having to do this respond to block each time. But in this stage, we're just trying to get MVP functionality, and I'm not super worried about it. Something to keep in mind, though. So what we're doing here is we're updating the current streamer's alert token. We're responding with the flash message, following the same pattern that we have before, and we're also going to return the new URL, and we're just going to use the widgets URL helper method here, which I'm not sure if we'll have access to in the controller. We'll find out in just a moment. But we're just passing in the newly updated streamer's alert token, and this will hopefully work. And then in the React component here, we're just making a basic request using our ksfetch function here, and that is set up to be able to handle that toast message, and then autocomplete just made me aware that I need to use a async wrapper on this method. And then basically, if we're getting a URL back in the data that's returned from this, we're going to go ahead and set that, and we should, at this point, we can reasonably expect that the toast message should appear and the URL should change, and if it doesn't, then that means that we have a bug somewhere. So if we reveal here, if we click this, we already get an error, so we know we did something wrong, but at least the message did appear. So we're at this point, being able to hook into the click event, just kind of like my mental process of going through what's the next steps and figuring out what the problem is. And if we open up DevTools, we don't see any exceptions. And we're actually getting a 404 here. Oh, we have this set up as a get HTTP verb. I think it would make sense to make it a post request instead. I think that should be fine. We can change that. Or maybe a put request, since it is technically updating. Go ahead and change the method to put in the reset token function here. Okay, we've got the token reset successfully toast message, but it's not updating and we're getting an error here. Okay, and it looks like the reason for this is we were anticipating this to use a set state hook, and we're just reading it directly off of the prop there. So we can go ahead and fix that. And we'll just have this initialized to the URL that we're passing in from props, which is going to cause an issue, of course, because of the naming. So we'll change that. We'll actually keep the naming convention here. I just ran into a little snag with the naming, but we'll keep the original URL as the prop there, and then we'll set the object that actually gets updated to current URL. And then, of course, set that to the URL initially. And then actually display the current URL here. So when we reset token, we'll use that set current URL. If we get the data.url, it should be the new token. If we go ahead and show, it's working as at least this far. And it appears that that is working. So now we have the ability to reset the refresh token as well as show it and have it copied to the clipboard. And Cursor was great in creating a lot of these elements. Again, anything that can follow a pattern, it does really well at. And then you can come in here and kind of clean it up and get it more dialed in. So I just noticed in the rendering of the URL here that we're getting widgets dot our token, and that is indicative of a problem. We had the widgets URL here, so that must have been either an autocomplete or just a goof on my part, but it needs to be, we actually had to add as alert to be able to get a named route here. I'm not 100% sure on why that is. I think it's because it doesn't know how to derive it from just this declaration here. That would just be my guess. But either way, the as flag here is what allows us to get this alert underscore URL that we should be able to use here instead of the widgets URL. And then we'll pass it that alert token and see if it renders properly now, which it appears that it does. So for the AnyCable infrastructure, here's what I have in mind. We're going to have two different Heroku apps, one for the clipshow.io hostname, and this is where the Rails app will be hosted, and we'll have this made up of web dynos and worker dynos. And then we'll have a separate Heroku app in the same pipeline for the AnyCable instance. And what this will allow us to do is we'll have this hosted on its own domain here separately from the Rails app. And then this will be made up of a dyno that just runs AnyCable. This will allow us to scale the web dynos horizontally and the worker dynos horizontally in any request that's being made to the Rails app. And the same thing with AnyCable. If we run into situations where we need to spawn more AnyCable processes, if we get to that point, we can do the same thing here as well. So how this will work is requests from the outside internet will go to the Heroku load balancer, and requests will sit there until a process or thread opens up to come and collect the request and process it. So in Rails, anytime we're processing one of our requests, a thread is taken up. And this is the entire reason why we want to use AnyCable, which is something that is a lot cheaper to keep concurrent connections open with. AnyCable is using Go under the hood, and Go's concurrency model is very lightweight compared to what Ruby can offer in the equivalent here. So it allows us to have this type of infrastructure where on a very cheap dyno, we can have a lot of concurrent connections handled with just setting up a few services like this. So requests will come into the load balancer, and it will sit in the load balancer until one of the web dynos has a open availability to take and process that request. And this is important for handling our WebSocket connections initially, because the AnyCable instance will make a request to the Rails app to authenticate this user given either their cookies or other authentication method. And then if ClipShow returns that that user is authenticated, AnyCable will keep a reference to this connection and will subscribe to any events on the channel in the shared Redis instance here that Rails and AnyCable will be set up to use. For that initial HTTP request from the AnyCable side of things to the Rails side, we're going to use a authentication token to make sure that only requests made with this authentication token that matches what's stored server side for both instances matches. Although I have the arrow going to the load balancer here, making it seem like it's not exposed from the outside internet, this will be treated like a regular HTTP request. It just so happens that these are both going to be hosted on Heroku's network. And if we are going to use this kind of infrastructure, this is likely what that request will look like to keep it internal. So in the event that we have a session going where the user's been authenticated and the AnyCable instance is set up to subscribe to any events that are published on that channel, this gives us the ability either from the web dyno or from the worker dyno to publish messages to Redis and have it automatically alert the AnyCable connection here, and then ultimately trickle down to the client. This will keep our Rails app able to handle requests for streamers or for any other thing that we need to handle in a single transaction, while in a very lightweight and an efficient way, handle all of the necessary plumbing to make this kind of concurrent connection and relationship work. Having Cursor go through the setup and being able to ask it questions, because I've never actually used ActionCable in production, or hardly at all really, has really been helpful, and I think this is a really great aspect to AI, and I really encourage anybody, even a seasoned senior developer, to be able to explore and ask it questions in a way that you can understand so that these concepts really are solidified. So far my understanding is we have a streamer connection, and this is what is going to be used in the streamer dashboard for any of the WebSocket functionality. How this basically works is we are declaring a very similar convention to where we're using current streamer elsewhere in the app. So we're calling this identified by current streamer function here. And what happens when the first request for the client to connect comes in, the connect method will run, and then we will find the current streamer based on that token that is going to be in the URL. So if that token is there, we'll go ahead and try to look for the streamer. If not, we'll go ahead and just return there because that's not a valid request. So if we can find the streamer by that token, we'll go ahead and log out to the Rails console or the Rails output and return the streamer. And what this does to maintain access to the current streamer object throughout different requests that we're going to have made and different parts of the WebSocket session is AnyCable will serialize this information and store it in its instance. And anytime a request is made over HTTP to the Rails server, it includes the serialized object in JSON for ActionCable to be able to deserialize and for us to be able to use that as the trusted resource. Because once it gets to that state in AnyCable, once we've gotten through the connect portion and we've been able to authenticate, the trusted mechanism there is going to be whatever requests are made that are valid from AnyCable, because we have all this infrastructure set up to make sure that only a trusted server like our AnyCable instance can get the application or a WebSocket connection to the state. So in our routes.rb file here, we are mounting the application cable streamer connection, which is that file that we just went over. And this is the URL that, from what I can understand so far, that the client will ultimately go to, and this gets proxied to the AnyCable instance. And then subsequently to receive AnyCable RPC requests over HTTP, AnyCable will just have all of those go through the /_AnyCable instance, and the deserialization of the messages and all of that will be set up. So that's why ActionCable and this AnyCable backend should really work well for us while following this Rails convention. During the setup here, Cursor actually set this as a method that we can use, but I think we will actually just call the broadcast method in the controller. Since we're building out that preview functionality, that's what that's going to look like. So we can go ahead and remove this method altogether. One thing I didn't account for when we were setting up our alert token encrypted column here is that we didn't anticipate we didn't account for the need to be able to query based on this encrypted value. So the reason this is an issue is we just ran into not being able to look up the streamer based on the token, even though the token did match. And the reason for that was the default encryption type is indeterministic encryption, meaning that each time that same value in plain text is encrypted, it will have a different hashed value. So there's no way to actually query that. So we're doing deterministic encryption, which is slightly less secure. But since this is something that we can cycle out for the user, it should still be fine. And I think this is still following a very good practice. As for the action cable setup that we have thus far, I did try to get this working so that we could have like scoped action cable servers, one for streamers and one for viewers. And it just wasn't working. I'm not entirely sure why, but for now we can just use this since we only have one type of user that's going to be using it. And then inside of our channel, we can, inside of our connection here, we'll be able to set up some different matching based on the URL that is being sent in for authentication. All right, so after continuing to work on this a little bit further, we did some digging, and somewhere here in the AnyCable guide, we were reading on the broadcaster being deprecated for Redis. So I guess what it looks like people are doing is just straight HTTP protocol. So in our diagram here, that would eliminate the Redis dependency altogether, and then that would move everything over HTTP. So if we have a message coming in this way, AnyCable will send it to ClipShow over HTTP, secured by our auth token. And if ClipShow needs to broadcast a message, it will be sent over HTTP as well to ClipShow, and then that will queue up the message and get it working. So a few changes here. We were using an AnyCable.YAML file. I think that's what Cursor made for us. We're back to the default cable YAML file. For the adapter, we're using AnyCable. This is the URL that you'll specify from the service for Docker. So we have that here. So we have AnyCable. It's on port 8080. And since this is running on the web service, we're able to use that AnyCable hostname for the Docker management there. I was reading in the documentation as well that if you don't have broadcast keys set, it will run AnyCable on a different default port on the AnyCable side. So in AnyCable's environment variable setup here, we set both the AnyCable HTTP broadcast path, the AnyCable HTTP broadcast secret, and that is going to be the auth token in production that will eventually make into a secure string that will get shared in between requests so that they can function as trusted sources. And then we can get rid of the Redis channel here since apparently we're not using that. And then I noticed in the logs that they were collecting telemetry, and there's an option to turn it off. It's anonymized telemetry, and I just felt like we don't want to have to worry about being in compliance with anything or anything like that. So I just disabled it for now. And then we have this streamer alerts component here, and I was doing some debugging here that we can go ahead and erase. And so there is a action cable Rails NPM module, and we have a create consumer method there, and we can set up the actual subscription by using that method. And we're passing in the action cable URL from the props. And so this is the view that renders in. So we're just using the React component, streamer alerts. And then another thing worth mentioning here is we are using a different layout. We're just using an alerts layout. Since this will be separate from the dashboard, there won't be access to current streamer directly through here because everything will be in that tokenized kind of path. So we're using a new layout here. We're including a new index.js and styles.css. This is matching the same pattern from the dashboard side of things. And then we do have the Vite React refresh token and the client tag that allows the hot module reloading to work with React, I believe. And so that is how all of that works. And then as a proof of concept, here is the current URL for the alerts for the streamer that we have in development. And it's just loading a basic heading here to show that the React component has rendered. And what ultimately happens, since we're hooking into this on the use effect hook here, anytime these props are changed, this will go ahead and run. We probably don't even need that. We could probably just remove that there so that this will just run once. And then the cleanup function here will get run when the component will unmount, if I'm not mistaken. So when we first load the component is going to set up the subscription using the Rails action cable create consumer method. And we can see the side effect of that here in DevTools. If we go into the network tab, we can see the first message is a welcome message. Then we have the subscribe, which is sent from that component. We get a confirmation that the subscription is there. And then AnyCable will just continue to ping this here. And I'm not sure if there needs to be a heartbeat handler on the front end for this. This ping just seems to keep going on. And I think it's something that AnyCable handles automatically, maybe. I'm not sure. Don't quote me on that. But now we have a active WebSocket stream. And what we should be able to do from the console here, as you can already see that I've been doing, we can broadcast to the channel that this is hooked up to. So it's streamer_2_alerts. And we're getting that from the streamer alerts channel. This is the convention for this. And we're streaming from this right here. And so this is unique to each streamer, and that gets set from the current streamer object, which is set from the connection here. And so far that seems to be working. There's a very good chance that I'm missing something, but so far this seems to be working, as we can demonstrate here. If we broadcast on this channel just a sample payload here, we were not getting this before. We were trying to like bridge the gap with Redis, and it was just like there was just an issue. I'm not sure if Redis is still actively used for PubSub, but that was the biggest issue with getting to this point. And then we can see that our message came in here, and we are actually able to receive data. So the next order of business will be to trigger the TikTok element that we need and automatically play a default video when a test event is sent to this page here over WebSockets. So in our Stream Alerts React component here, we've got the functionality working, it seems. We'll have to test it a little bit more, but it looks like it is working, where when the component mounts, we will set up some listeners for the setting of the URL, which actually makes the iframe render. And then once the iframe renders, we have the handle iframe load method handling the different events that can happen now, and we're making sure to limit the post message payloads that only come from TikTok, so that if there's anything else in the browser, add-ons or anything like that that's using post message, we'll be able to see that. And TikTok includes this flag in all of the messages that they send. So we'll limit it to make sure that we're only handling payloads that are coming from where we expect. So we modified this a little bit to listen into that event. And when TikTok gives us the on-player ready event, we'll go ahead and set loading to false, which will change the UI down here. Displayable to true. So what we're doing here is we've added opacity, and that's how we're making it toggle on and off for now. We may change this. And then what I'm doing here is we've added a prop for play on load. So by default, when the TikTok preview loads, it won't autoplay. But in the event that we're loading the TikTok preview in a stream alert, we do want to have it autoplay, because that's the mechanism that will have the functionality for what we need. So this event here listens to each frame as it progresses, and there's a comparison that we can run here. The current time it'll give you, and we can compare it to the duration. And I'm just hiding it early 2 seconds so that it'll hopefully be a smooth transition, just to try to get it to work. We may play with that more. So if that prop is set when this happens, we'll set displayable to false, which will turn the opacity down to 0. We're using Tailwind for that, and I did not mention yet, but we had to add in our alerts styles.css file the Tailwind setup and declare that the sources in our Rails view and in the alerts components are going to be sources for Tailwind to compile those classes into CSS styles for us. We also added a route to get widgets test here, and we're having that go to the widgets controller on the test action. And in our widgets controller here, we added this. And this is how we're able to broadcast using ActionCable. So now that we have this set up and we're using the HTTP broadcast type and we have that all sorted, this now is working. So to broadcast on the channel that the streamers subscribe to, we'll do the same thing that we were doing in the Rails console. We'll just do it in our controller action here. And this payload is set up to digest a type and then a clip payload. And we just have a generic video ID here. And it's the same video ID that comes from the TikTok documentation. They use a sample video there. So we're just using that as a sample video as well for that test alert. And what we're looking to accomplish here is we have in this window to the right, we have that URL that includes our secure token. That's this URL right here. And what we should expect is when we click test clip, it should show up the TikTok video and it should automatically start playing. And I'm not sure why it seems to be inconsistent in Firefox here. There's something with having to interact with the page before it loads in order for it to autoplay. Now what we can do to test this in OBS is I've set the main input source here to not be my desktop anymore so I can try to illustrate this better. So in OBS, we have a new browser source added and we've called it ClipShow. And we're just setting that browser source to the URL that we just tested in the Firefox browser. So we're setting this width to the entire width of our stream. That's what's outlined here by the red box. And when we trigger that test clip, we should have the TikTok emulate the same thing that we just saw in Firefox. And it seems to work better with the autoplay. It seems to be working every time. So to illustrate that, I will go ahead and click on the test clip button. I know you can't see it because it's just a blue screen, but I'm clicking on the test clip button now. And we need to refresh this. So I have the screen set to a blue screen here so you can see the overlay a little easier and it's not just, you're not confused as to where the actual TikTok is coming from. So if I press the test clip button here off screen, we see that it does come through and there's audio. And then after it's done, it disappears. The audio goes a little bit longer than the video goes for, so we might have to adjust that. But this is tremendous progress. This is the very basics of completed functionality for being able to use a real-time connection via ActionCable and AnyCable to trigger events. And we're just doing it with the test event right now, but hopefully you'll easily see this will lay out the foundation for how we can have another interface towards the user or the viewer in that case, trigger events and have it display on the streamer's OBS, just like we demonstrated. After much trial and error, it appears that we finally have AnyCable set up, working with HTTP broadcast and working in the context of our test alert proof of concept here. I struggled with this over a full stream trying to get this figured out. I thought I had it figured out using the HTTP broadcast method, where actually, when I did get it working, I actually had it working unknowingly with a Redis pub sub event set up, and I didn't even know that that was the case. So that's totally on me. But now, the way that I found that out was I removed the AnyCable Redis service that we were using here in the Docker Compose file. And once I removed that, everything stopped working. So I had to go back to the drawing board and figure things out. And in my defense, I think this is a little needlessly confusing. At least the documentation, in my opinion, wasn't the most clear on how to set this up. Maybe it's just because we're using the HTTP broadcast method, trying to future-proof ourselves from further versions of AnyCable. We found out that AnyCable specifies in like one area on their website that version 2 plans on deprecating PubSub over Redis. I got confused and thought that it was already deprecated, which threw another spanner in the works as well. But for now, we don't have Redis as the PubSub adapter. If we end up wanting to change that for whatever reason, now that we have a better understanding, we should be able to do that. And we've slimmed down our AnyCable Docker service here. And what I did to try to figure out what I was missing was use the AnyCable setup generator that I didn't cover in a recording. But part of that video, part of that process goes through asking if you want to have AnyCable set up in your Docker Compose file. And it will give you a sample service declaring the WebSocket. They call it WS by default. I changed it to AnyCable. It seems to be a little nicer in the logs for me. And it will show you these environment variables that you need, except for the broadcast URL. Another weird one that I had to track down manually. By default, this has it on 8090. And even though the AnyCable documentation says that that's the fallback functionality if you don't specify the AnyCable secret, which we are. We're specifying it here, and then we're also specifying it in the AnyCable.yaml. Now, there's two different YAML files that we need to configure here. Yet another thing that I was confused by. So in config AnyCable.yaml here, this is the default, well, it's slightly modified, but it came from the generator from AnyCable, the AnyCable Rails core gem. And so basically, this is how we have it set up. Broadcast adapter, we specify that to HTTP instead of Redis. I don't think this one matters. And then we had to specify the broadcast URL, and we're passing in the AnyCable hostname because this is going to run in the context of the web server. The web server can use the Docker hostname to be able to route it to that, and we had to specify that in order for it to work, and it automatically generated the HTTP RPC mount path for me. Part of the generator's prompts was, how would you like to use RPC? And we were able to select HTTP RPC on that. And then for now, we're just having the secret in plain text. As we get closer to production, we'll figure out a more eloquent, secure way to get a random generated secure string that we can use for the secret here. Okay, so to demonstrate that this is working in OBS, which is the software that I'm using to record this video right now, we have a browser source that, if you can see where my cursor is, should show up right here, not on the actual ClipShow page. So if I press test clip here, that starts, it plays, and then we should have it set up still to just hide after it's done, which functionality of that hasn't changed. So that is the proof of concept working confirmed now without Redis involved, which may or may not be the recommended way to go. We don't know. But again, getting back to the time box concept, when I went over how we spent a lot of times chasing our tail trying to get Chrome working in its own service, working with Docker, and as we did some digging, we found out that Chrome may have deprecated the remote debugging address or whatever the case may be. We ended up spending way too much time on that, right? And so we need to figure out a fallback when that happens, particularly when we're trying to get things done by a deadline. Although this is our own project, my resources are super limited, and we need to make sure that we're being diligent if this project's going to see the light of day. So although we obviously could have gotten it working with Redis, we proved that unknowingly once. We're working with HTTP now. It's something that is independent enough to not have any configuration issues, at least at this point. So I think it's okay to move on to more of the nitty-gritty details, getting this closer to our finished MVP.
And that's going to be a wrap on episode 4, a long-awaited episode that finally gets into the exciting real-time functionality that we're using AnyCable Go hooked up with ActionCable for, and I think it's going great, despite the roadblocks that we hit in this episode. We were able to demonstrate the very first iteration of our proof of concept of this new implementation in our OBS broadcasting software, which is ultimately the platform that ClipShow is going to be performing on. So the fact that we already have some existing functionality working to the point where we can demonstrate that is so exciting. The roadblocks that we hit with the Chrome debugging and the AnyCable stuff really is a great opportunity to give some attention to how important time boxing is and making sure you're being diligent with your resources, whether you're a solo developer or you're a professional engineer on a team of other engineers. The foundation we built today, from the WebSocket functionality to being able to generate a secure token that streamers will be able to use to easily implement ClipShow into their streaming software, will serve us for the rest of this project, as it's really the core of what is going to make ClipShow work and unique and engaging and fun. Next episode, we'll dive deeper into the viewer experience of things, and the first thing we'll need to build is a robust queuing system for when these alerts come in to trigger our different clips. And that will definitely present some interesting challenges that we'll have to face. As a reminder, if you'd like to follow along in this progress, I stream nearly every day live on twitch.tv/oddjob. So make sure to follow us there now so that you won't miss our next live stream, where we do a little bit of gaming, but mostly coding, and we're very excited on getting the MVP for ClipShow finished. When we live stream, you'll be able to see the real struggle, the debugging, and you'll have an opportunity to ask questions from someone who's been in the industry for well over a decade. Regardless of if we'll see you in a live stream, if you like this kind of content and want to see us make more, please don't forget to hit that subscribe button, give us a thumbs up, and leave us a comment. Thanks for watching, and I'm very excited to see you in episode 5. Take care.